This video is a review for 7.1 and 7.2 for Geometry Block. Ratios or proportions are about relative values. They can be written three ways: as a fraction, 1 over 3, with the preposition to, 1 to 3, or with a colon, 1 to 3. Two different ratios, like 2/3 and 6/9, are considered proportional if you can multiply the first ratio by the same number in the numerator and the denominator and get the second ratio. Another question you might be asked is, are these ratios proportional? So if you had 2/3 and 6/12, you could look at what the factors are for the numerators, like times 3, and the denominators, like times 4, and are they the same scale factor? No. So they're not proportional. Activity 1 assigned these three basic ratio problems, and notice that there are variables x, y, and t to solve. So the video showed this cross multiplication method. X times 16 equals 2 times 40. So you simplify and you divide and you get 5. And what that means, if you were to plug in a 5 here on the top of the left ratio, then those two ratios would be proportional. Number 9, same steps, cross multiply. 189 is equal to 21y, divide by 21, y is equal to 9. If you were to plug a 9 in there, these ratios would be proportional. It's not 100% necessary since we have calculators, but you can start to simplify these. For example, 7 and 21 have common factors. I could change this 7 to a 1 and this 21 to a 3 by dividing both by 7. Then the problem gets a little bit easier. 27 is equal to 3y, and I still get the same answer. Optional. That trick works here for number 10 also. Let's say I divide the denominators by 29. This 58 becomes 2. And 29 becomes 1. So if I cross multiply, I get that 6 is equal to 2t, and t is equal to 3. If that blows your mind a little bit and you just want to do straight multiplication, still works. You would get this, divide by 58, and t is equal to 3, either way. To throw one extra curveball at you, what about if we have a quantity x plus 3? Well, we can still do the same cross multiplication, but we keep that x plus 3 inside parentheses. That way we can just distribute the 15 by multiplying 15x plus 45 is equal to 120. We subtract 45 from both sides, divide by 15, and we get that x is equal to 5. Another type of question we might see with ratios is one like this, where we're looking at a bag that has 10 blue marbles, 5 red marbles, 7 green dice, and 8 black dice. The question will say, what is the ratio of blank to blank? And you can plug in different things. For example, blue marbles to total marbles, which would be 10 over 15, because you have to combine the 10 and the 5 to get the total marbles. But we typically reduce these. So we would convert this to 2/3, because you can divide the top and the bottom by 5. If you have one of those graphing calculators, you can press Math, Enter, Enter to automatically reduce. Otherwise, just think about it and divide by the largest possible number. So we could change this so that the green and the black are also marbles. Green marbles goes on top and total marbles goes on bottom. Often we're putting the total on the bottom. And we would get 7 over 30, which cannot be reduced, so we're done. Number 16 from the previously assigned activity involves the length and height of two different buildings. We're comparing the Arkansas State Capitol to the U.S. Capitol buildings, and they are proportional. So given 3 of the measurements, we can figure out the 4th. So there's 2 different ways to set up my proportions, probably more than that, but one way would be to consider the U.S. Capitol building's length compared to the Arkansas, and then the U.S. height compared to the Arkansas height. But I could also just think about the proportions of the U.S. building, its length compared to its height, and do the same for the Arkansas building. And if you actually set up the cross multiplication, you'll see that 752 times x happens in both proportions, and 564 and 288 just switch spots. So that's why both of those are correct. You have to pay attention to the length and the height and which goes to which building to set it up properly. That's why I suggest labeling things like this. Your final answer will be 216. In 7.2, we looked at similar triangles, and the 2 key points for those are that the angles are congruent and the side lengths are proportional. So say we had these 2 equilateral triangles. The one on the left has side lengths of 5, 5, and 5, and the one on the right, 10, 10, and 10. We just doubled those side lengths. This is called a dilation. And the number that we multiply is called a scale factor. So here the scale factor going from the left to the right would be 2. And if our side lengths are getting smaller, then our scale factor can be a fraction. Triangle similarity statements help us identify which angles are congruent and which side lengths are proportional. For example, given this similarity statement that triangle ABC is similar to triangle DEF, and that's what that little squiggly means, similar to, we know that A and D, the first letter, are congruent angles. And same thing for B and E and C and F. What that means also is that this segment AB is proportional to this segment DE. Similarly, segments BC and EF are proportional, and AC and DF, just based on the position in the similarity statement. You don't have to look at the diagram. So for example, if we had this triangle on the left with a side length of 6 and the one on the right was 3, then if this length was 10, we can figure out the pattern that this one has to be 5, because it's half of the one on the left. And if this was 8, this might be 4. And these triangles are considered similar. It can be confusing when these triangles rotate. Now, I didn't rewrite things upside down, but you might be tempted to try to match up based on the relative positioning. Go with the letters in the similarity statements instead. For example, number 19 in the first activity. If ABCD is similar to EFGH, we know that 4 is proportional to x plus 3, because AB corresponds to EF. Similarly, 3 corresponds to 2x minus 4, because BC matches up with FG. Remember, when we cross multiply, we're going to keep the expressions like x plus 3 and 2x minus 4 inside parentheses. That way we can distribute. So the 4 will be multiplied by everything inside the parentheses, and the same with the 3. That's the most common mistake. We forget to multiply the 4 by the second term, for example. So let's move 3x over, add 16 to both sides, divide by 5, and x is equal to 5 in this problem. In 20, if the diagram is not obvious, you can match up MP with XZ. And you can do the same thing for PN and ZY. And based on their positioning, you know that these are indeed proportional, those side lengths. Of course, you could just eyeball it and hope that they're the right ones and say the small over the long and the small over the long, but that doesn't always work. Here's how I would set up my cross multiplication. Here's how I would distribute and move all the x's to the right and the numbers to the left. And when I divide by 45, I get 15 as my final answer.